Hey students, this is the start of lesson 8.3. We're going to do lesson 8.3.1 today. We're going to look at quadratics a little more closely and try and understand the effects of the different parts of the equation A, B, and C on them. We're going to do more with analyzing projectiles in motion using quadratic equations. And we're going to learn how to distinguish between quadratic relationships and other types of relationships eventually. So we've got a lot going on here. I'm going to just pause here and just let you read this first paragraph or two, and then I'll catch it back up with you. So go ahead and pause here now. So we're going to skip to this problem here, and we're going to analyze a little more deeply how changing an equation a little bit changes the outputs of the equation and the graphs of those equations. So I think what I'm going to do is have you fill in this table. Go ahead and what I would use if I were to use a graphing calculator, but basically for this first equation we just have to multiply the number by itself. And then notice this, that as I'm filling in these numbers, we can use the idea that quadratic equations are symmetric, so eventually you're going to reach like a minimum or a maximum, and then you can start changing. But if we multiply negative 2.2 by itself, we get 4.84. Then we get 1. Then we get 0.25, 0. And at that point, we're at the lowest possible. So now we're going to start going back up again. And it's just a mirror image of those numbers at the top of this column. And as much as you can, use just how we're changing this equation to figure out the next one. Like here we're taking x squared and we're adding 1. So I can just do 16 plus 1 is 17, 10.24 plus 1 is 11.24, 4.84 plus 1 is 5.84, and so on. And again, we have a mirror image, so the lowest we're going to get here is 1, and now we're going to repeat those numbers. So just look at the numbers here. Those two match up. This one's going to be 2. The next one's going to be 5.84, and so on. And I'm going to pause here and just let you fill in the rest of the table yourself. Again, use this. Now we're going to subtract 1 from this number, so you know that's going to be 15, and so on. So I'm going to pause and check back with you. All right, so the table is complete, and now we're going to answer some questions by looking at these values. Compare the values in each column B through F with those in column A. Explain how the comparisons are related to the equation. So when we went from A to B, we noticed that all these numbers are 1 more, and we added 1 in the equation. So plus 1 in equation means the output values are all 1 more. Okay, and then when we went from A to C, so from this one to this one, again we had minus 1 in equation, and that meant that our output is 1 less. From A to D, these two, we instead of x squared, we have negative x squared, and the negative x squared just made all the outputs opposite. From A to, oh, we got one extra one here. From A to E, so from there to there, what we did is we added 1 inside the parentheses. And what that does, that one's a little trickier, but if you look closely at some of the whole numbers, you'll notice that it has the same output for 1 less input. So like this output of 4, well, this output of 1 right here actually happened as an input of negative 1 on this one. The output of 0, it shifted 1. So the output, the same you get the same output for one less input. And from A to F, you get the same output for one more input. And notice we subtracted 1 in that equation. All right, now to match these graphs, we're going to think about what we just wrote there and just decide which graph goes with which equation. We'll start with this one. This is just y equals x squared. And then it says describe how the graph difference. Well, this one isn't different, it's the same. And then it says describe the graph's line of symmetry, and that's the y-axis, which is the equation x equals 0. So right in the middle there. All right, now let's think about that. And notice that on this one, we shifted the line of symmetry over 1 to the left. So we're really getting the same outputs as we are for this one, but we're getting them for one less on the input. And what that one would be is this one, where we went from A to E. And equation E is y equals x plus 1 in parentheses squared. And then how's the difference? It shifted 1 unit to the left. So adding 1 in parentheses shifts our graph 1 unit to the left. And the line of symmetry is now x equals -1. Okay? Let's do one more here, and then I'll let you do the rest of them. So this one, you'll notice there all the values are 1 down, so the outputs are all 1 less. And the equation where we saw that was x squared minus 1. And we can say it shifted 1 unit down. And the line of symmetry is exactly the same as for our original y equals x squared, which is the y-axis, or x equals 0. All right, you can match up the other ones and fill in the reasons for those. Okay, I want to do a couple more problems here. We're going to also learn how to write equations by matching up numbers to a specific equation. You'll notice this first one table here is just y equals x squared. So I'm just taking the x value and multiplying it by itself. And we're going to relate all these other tables to that and try and write the equations by doing that. So look at the second table. And what you might notice is that our y equals x squared, our first table, this one over here, is actually the last number in all of these. So what we can say here is that these are all 100 more than those there. So if I just add 100 to my x squared, I'll produce these. And just to make sure that works, you might try it. So if you did x squared, like let's say we take 3 squared. 3 squared is 9 plus 100 is 109. All right. Now if we compare this table to that table, you might notice that all these numbers are less than these numbers. So here we have 9, here we have 5, here we have 4, here we have 0, here we have 1, here we have -3. Well, if you look closely, they're all 4 less than our original table. So it makes sense that this equation is y equals x squared minus 4. All right. I'm going to do one more that I think is possibly a little bit different, and then we'll do the rest in class. Okay. Let's look at number 13. Now, how has that changed from our original? Here's our original numbers. Here's y equals x squared. And I hope you notice here that these are all 10 times bigger. 9 times 10 is 90, 4 times 10 is 40, 1 times 10 is 10. So we can just multiply our x squared by 10. So y equals 10 x squared. And that's that one. And I think I'll let you do the rest in class. So that's the end of this video. I'll see you tomorrow.